selective reduction. So here, AB1 and 2, they are the same molecule. But2 enal under either H2 and Ni or LiAlH4. With H2 and Ni, all the double bonds are gonna be reacted. With LiAlH4, only carbonyls are reacted. So this becomes an alcohol, but it still remains an alkene. This happens because LiAlH4 is actually nucleophilic. So text is a nucleophile and will only reduce anything that is positive. Whereas C double bond C requires an electrophile. Oxopentanoic acid So I think I wrote oxopentanoic acid twice. Again, this was one with the double bond H and one with LiLH4. But in both cases, this will reduce to the alcohol. So both cases, whether you use H2 or LiLH4, you're gonna get the same compound. Okay? Now, so now, general reactions of carboxylic acids. So we have carboxylic acids, amines, derivatives, amides, nitrides. Said quite a few. Oh, the pleasure of chemistry. What more do you want in life, Amy? So, AC, CH3, COOH, plus Na. I'm gonna do half H2 plus propano plus sodium carbonate. This will be the salt. Plus CO2 plus H2O. That will be 2 and 2 there. Okay. Ethanoic acid plus phosphorus chloride. I underestimated how long these were gonna take, naħseb, eh?
Yeah.
Because if they're taking.
Don't inzjaw nofs.
Alright, without you, I would have finished them in an hour.
Xorta ma. Ħatti għusija daw, għala kif tiktibhom.
Without you, I would have finished them in an hour. Maybe an hour 15. Butyric acid with a reducing agent. Imma ismawni, there's something I tell you for these. It shouldn't take you much more than me, because the main problem is that I have to write them. And I don't write faster than you. Mm. Okay. Propanoic acid with methanol. So this is esterification. And that would be the reactions of carboxylic acids. The only reaction that you don't have here, but we have at another position. Okay? AE2. Actually, I think I'll tell you to skip that. But the main scenario is going to be to actually try and understand all of these. Now, metanoic acid is one that has some very weird chemistry. And it's weird because it can do things that others can't. So I'm gonna add one that's not actually written plus PCl5. So the first one actually forms CO plus H2O. This is a drying agent, this is a dehydrating agent. It will actually okay, it will actually react to dehydrated. This will oxidize it. This will oxidize it. It's the only carboxylic acid that can be oxidized. And this, you form CO plus H2O plus POCl3 plus HCl. Okay? Now, dicarboxylic acids, ethane dioic acid, or you know it as oxalic acid, can react with concentrated sulfuric acid, oxidizing it to form CO2. So can be oxidized to CO2. I'm gonna skip the second one. And butene dioic acid, when heated, it depends. If it is cis, it reacts. But if it's trans, there is no reaction. And in fact, it is a test for these. Okay? Then we're gonna have acyl chlorides. For acyl chlorides, this is going to be all with ethanoyl chloride. So I'm gonna write ethanoyl chloride once, and it's plus H2O plus CH3 CH2 OH plus NH3 plus CH3 CH2 NH2 and plus CH3 COO Na. The first one will be to form the carboxylic acid plus HCl. The second one forms the ester plus HCl. The third one is the amide plus HCl. Another amide, but this one is a substituted amide plus HCl, and the next one is the acid anhydride plus HCl. Okay? Now, reactions of esters, and as you see, these reactions are all the same, meaning yes, they might be a little bit different, but at the same time, they are all the same. Esters. Ethyl ethanoate with H2SO4 H2SO4 is the catalyst to give the acid plus the alcohol. Methyl propanoate this is gonna be a basic hydrolysis. So here you have to be careful, because if it's a base, you're not gonna make the acid, you're gonna make the salt. With ammonia, you're gonna make the amide issa. Methyl ethanoate with lithium tetrahydroaluminate will give the reduction. So this can also be reduced to give the two alcohols. After this, you have the amides. So again, it's patterns, it's finding the patterns. Okay, it's finding the patterns. Yeah, man. Okay, and if you can find the patterns, that will be something that will be extremely, extremely important. So, I'm gonna do the amides one. Yes, amides. I will try and finish. I'll see what I can finish. So, ethanamide with hydrochloric acid is the same like esters. You're gonna hydrolyze it. I ate my التشيخ.
Ija. Diġà. Dal-chemistry.
نفهمك توش تنكويتا. Ethanamide with aqueous sodium hydroxide. And again, here you're gonna form the salt. Ethanamide with phosphorus 5 oxide, so P4O10. This will remove water, forming the nitrile with bromine and then NaOH. This is the Hofmann degradation. So here you will lose CO2. And ethanamide with LiAlH4. This is a reduction, and you'll form the amine. So the last two reactions are both reactions to form amines. But one is a reaction to actually remove a carbon. You decrease the carbon chain. The other one is a reaction during which you are reducing the amide to an amine. Now, basic properties. CH3, CH2, NH2 to give. But they said, imagine the reality didn't say the record, yeah. And I have to start the recording again. You wouldn't be here, only I would be speaking for myself. Or, because I'm a good teacher, and I think you learn better when you actually explain things yourself, I will ask you to explain. Now, phenylamine would need a very strong acid to actually form the salt, simply because it doesn't really want to be acidified. The lone pair is onto the ring, okay, and therefore it will need a strong acid to be acidified, but H2SO4 is a strong acid. Alkylation, so this was a J. Ethylamine with chloro ethane. This is an addition. Okay, this can further react both to form a quaternary salt between the two or to substitute another time. Phenylamine with ethanol chloride This is similar to phenols, where the ethyl chloride is strong enough to react and form the amide. This will not form a quaternary result. This will not be reactive with an acid. And for today, I'm gonna stop. For now, I'm gonna stop here. And I'll send you the rest later on. Okay? Thank you.